The power rule is one of the first derivative rules that we're going to talk about. And what it refers to is when you've got, say, a function f of x equals x to the n, and we can ask what's the derivative of that. So in the special case that f of x equals x squared, we already figured out straight from the definition that the derivative was 2 times x. In general, the derivative of this function is n times x raised to the power of n minus 1. So when n is equal to 2, you get 2 times x raised to the first power. That's just 2 times x. And in this setup, n can be any real number. It doesn't have to be 1 or 2 or 3. It could be negative. It could be negative 14. It could even be pi. So x to the pi, its derivative is pi times x to the pi minus 1. However, for the purposes of showing you what's going on, what I'm going to do for you today is to do this in the special case that n is a whole number. So it could be 1, 2, 3, so on and so forth. And once you have this, it's not too much trouble to go on and do it for all exponents. So in order to show you how to calculate this derivative, or at least to show you why this is true, let's go straight back to the definition. So let's look at the limit as h goes to 0 of f of x plus h minus f of x all over h. Here my f of x is x to the n, so when I plug in, I'm going to get x plus h raised to the nth power minus x to the n all over h. And that's something I'm going to have to calculate. So then here's the problem. So how do I handle x plus h to the n? Well, the way that we handle that is with something called the binomial theorem. And it basically says that if you take a binomial, that's a sum of two numbers, and exponentiate it, then here's what you're going to get. You start out with x to the n, and then you add to it, well, it's going to be a term with x to the n minus 1, and then times h. And then you have to know how many terms you have, just like this, and the number in this case is going to be n. And then you keep on going. You have x to the n minus 2, and then h squared. And how many of terms of these do you have? Well, what we do is I'm going to put here something called the binomial coefficients. And this notation, you read it by saying n choose 2. It's equal to n factorial over 2 factorial times n minus 2 factorial. That's the number of ways that you can choose two things from a collection of n things. And I'll make perhaps another video to show you why the binomial theorem is true. And you keep on going like this all the way until you get to h to the n. So your second to last term is going to be n times x times h to the n minus 1. And then your very last term is just going to be h to the n. And all those binomial coefficients, 1 plus n choose 2, all the way over, when you add them up, it has to equal 2 to the n, because if you have two things and raising it to the n power, that means you're doing 2 to the n multiplications. So finally, when you plug all of that in, here's what's going to happen for you. you're going to get this x to the n, and you're going to subtract that x to the n to give you 0, and then what's in the middle is going to be left over. And if you look at every term after x to the n, each of those terms have an h in it. So factor out that h. So I'm going to get h times n to the x raised to the n minus 1. So that's where this is going to come from. And then the next one is going to be n choose 2 times x to the n minus 2, and then times h, because I factored out 1h, and then keep on going. You end up with just h to the n minus 1, because again, you factored out that h. And then you divide by h. So now you can simply cancel these two, and what you're going to be left with is taking this limit. And so this limit, as h goes to 0, well, you have a constant because the h was canceled, and then everything else is multiplied by h. So all of this stuff is going to go to 0, it's going to go to 0. And what you're going to be left with is just n times x to the n minus 1. And that shows that formula. So for instance, if you wanted to say, like, what's the derivative of f of x equals x cubed, automatically now, without having to go through that whole process, you know that answer is 3 times x squared. So for instance, if I say take f of x equals x cubed and find for me the tangent line that goes through the point x equals 2, what you'll be doing is you'll be looking for the line with slope given by f prime of 2. So that's 3 times 2 squared. So the line with slope 12, and that goes through the point. X equals 2, and y equals 2 cubed. 2 cubed is 8. And now that you've got the slope and the point, you could just write down the tangent line. So it would just be 12 times x minus 2 plus 8. So using this power rule, you now have like a lot more derivatives that you know how to take. You have a lot more tangent lines that you know how to find.